Hello, and welcome to Kantian's versus Einstein's Relativity. My name is Layla Gipson, and today I'll be presenting on the reality of relativity, its impact on Kantians, and how Kantians interpreted relativity. Today, special and general relativity are considered extensively confirmed. However, when they were first published, they were the subject of heavy scrutiny and repudiation by Kantians, understandably so, given it threatened some of their most basic assumptions about reality. Rather than abandon Kant, neo-Kantians claim to reconcile Kantianism with relativity through abandoning or reinterpreting his physics claims, much of which came from Newton, while retaining most of his philosophy/epistemology. For the sake of this presentation, though, we will focus primarily on strict Kantians. Below is a quote from Einstein blatantly stating that relativity and Kantianism are at odds. He says, quote, "Until some time ago, it could be regarded as possible that Kant's system of a priori concepts and norms really could withstand the test of time. This was defensible as long as the content of latter science held to be confirmed, did not violate those norms. This case occurred indisputably only with the theory of relativity. However, if one does not want to assert that relativity theory goes against reason, one cannot retain the a priori concepts and norms of Kant's system. So, what elements of relativity cause problems for Kantians? 1. Space and time are relative to one's frame of reference. Both are relative and dependent on the motion of the observer and their gravitational environment. 2. Space-time is 4D and non-Euclidean. It is quote, a way of representing positions in both space and time, including all three spatial dimensions along with time results in a four-dimensional space-time, where any point in this space-time can be represented as a four-twelfth of where x, y, and z represent the usual three spatial dimensions and t represents time. 3. Space-time itself is an objective physical reality. Minkowski's space-time interval accounts for the discrepancy in flat space-time between individuals' relative experiences. When gravity is involved, non-Euclidean Riemannian geometry must be used. Mass and energy bend space-time, meaning the geometric features of space-time are determined by their distribution. 4. Simultaneity is relative to frame of reference. Events that are simultaneous from a moving point of view are not simultaneous from a stationary point of view. As an example from the Do It textbook, Sarah and Joe will agree on all the direct empirical data, but they disagree on issues involving how much time has elapsed, how far apart objects are, and whether events are simultaneous. Each are right from their respective frames of reference. 5. Time dilation and length contraction occur. The principle of the constancy of the velocity of light plus the principle of relativity give way to 1. Time dilation, meaning time passes more slowly by a factor of the Lorentz-Fitzgerald equation for people and objects in motion. And 2. Length contraction, meaning that distances shrink by a factor of the Lorentz-Fitzgerald equation for people and objects in motion. Time slows and length shorten the faster objects are moving and/or the nearer they are to a strong gravitational field comparative to a stationary observer. Distances shrink only in the direction of motion. 6. Gravity is the curvature of space-time due to bodies, not an attractive force between bodies. For example, Mars, like any body in motion, moves in a straight line, but a straight line in a curved space is a geodesic. A body such as the Sun will result in a curvature of space-time, and according to the equations of general relativity, this curvature is such that the geodesic on which Mars should move would appear to be an ellipse about the Sun. And 7. Light deflection occurs due to gravity. Since light will take the shortest path, light passing near a large body, such as the Sun, follows what appears to be a curved path. Einstein mentions a priori concepts being relevant to Kantianism a few slides ago. But what does this mean? On this slide are a few helpful definitions to keep in mind for our discussion. 1. A priori refers to how something is said to be known non-empirically. Its opposite is a posteriori, known through experience and so connected to empirical knowledge. A given proposition is knowable a priori if it can be known independent of any experience other than the experience of learning the language in which the proposition is expressed. An a priori concept is one that can be acquired independently of experience, which may but need not involve its being innate. 2. An a priori can be analytic or synthetic. A synthetic a priori proposition is one which the predicate is not logically or analytically contained in the subject, i.e. synthetic, and the truth of which is verifiable independently of experience, i.e. a priori. Now, on to the Kantian position. If we wish to understand and judge their interpretation of relativity, we must first know where they stand. They believe 1. Euclidean geometry necessarily holds for all people regardless of frame of reference, so across all human perception. That this is the case is a synthetic a priori. Spatial intuition is Euclidean in nature. Geometry is also necessarily Euclidean, not because of logical necessity, but because of the necessity that all experiences of our outer sense depend upon the pure form of the intuition of space. 2. Space and time are Euclidean and necessary, subjective, a priori forms of intuition, meaning they are impositions of the human mind on reality that are necessary for understanding and experiencing reality. So lengths and relations in time, like simultaneity and the order of events, are objective in the phenomenal world / human perception. Euclidean space Euclidean space is the pure basis of Kant's transcendental philosophy. Time cannot be an empirical concept, nor can it be drawn from experience. Thinking of space, time, and motion as absolute, or at least from an absolute point of view. This means that one regards space and time as existing independently of matter and relations amongst material bodies. 3. Attraction and repulsion are the two fundamental forces of matter, and gravity is an attractive force between bodies. So they also believed in a universal gravitation from Newton. Kant accepted Newtonian characterizations of gravity and attraction between masses, however, thought that Newton's philosophy of nature did not reach to its limits. His goal was to give a better metaphysical foundation to Newton's natural philosophy by improving it with Leibnizian's thought system. 4. Belief in transcendental idealism. According to Kant's philosophy, we experience a real, non-illusory world, but only as it is structured by our mind, not as it exists independently of us. Human cognition is limited to objects that somehow depend on our minds. Things in themselves are beyond the limits of our experience and cognition. They exist, but we cannot know them. Space and time are nothing other than merely forms imposed by the mind, so everything we experience in space and time, spatiotemporal objects, are merely appearances. Our categories apply only to these appearances. With all this in mind, the Kantian interpretation of relativity looks like so. 1. It supports a relational ordering of events, consistent with Kant's rejection of absolute time. Events are ordered not in relation to absolute time, but only as lawfully determined phenomena in mutual temporal relations to another. 2. It confirms that man cannot directly perceive time, because time is relative to frame of reference. The view that time is an imposition of the mind is reinforced. The relativization of time measurements show that Kant correctly maintained that time is not an object of perception. 3. Eliminates Newtonian metaphysical notions like absolute space, time, and the mysterious absolutism of action at a distance. And 4. Confirms or at least does not detract from other a priori principles. These presuppositions have been confirmed by the general theory. They are spatiality and temporality, the law of causality, the principle of sufficient reason, and the conservation laws. Faced with relativity, if one were a strict Kantian, believing in Kant's physics, philosophy, and epistemology, they would have no choice but to either deny Einstein's and many others' findings or reinterpret and cherry-pick what aspects of Kant's view to retain / abandon, making them a neo-Kantian, like Winternitz, Natorp, and Einstein himself to some extent. The following are some examples of neo-Kantian interpretations. 1. Relativity reinforces or does not detract from the idea that space and time are not empirical objects but necessary, subjective, transcendental, a priori concepts underlying experience. And as we saw towards the beginning, Einstein disagrees with this understanding. In revisionist fashion, the Minkowski principle of relativity was welcomed as a more consistent carrying through of the distinction between transcendentally ideal, purely mathematical concepts of space and time and the relative physical measures of space and time. B. The appearance of non-Euclidean and multidimensional geometries in physics and mathematics are to be understood only as valuable tools in the treatment of special problems. In themselves, they furnish no new insight into the transcendental logical meaning and grounds of the transcendental and purely mathematical determined concepts of space and time. still less do they require the abandonment of these concepts. One could say the phenomenal world is curved by the factor which Einstein states, gravity, motion, distribution of matter, but not the noumenal thing in itself one. 3. The concept of a priori knowledge as a necessity is maintained. Neo-Kantians may change what the a prioris is and or its interpretation. With this, my presentation over Einstein and the Kantians comes to an end. Thank you for taking the time to watch. The next two slides, this and the next one, are just extra, covering some of Hans Reichenbach's understandings of the philosophical implications of relativity for those interested. And the second slide of that. So here's the bibliography. And yeah, goodbye and have a blessed day.